Hi, I'm Christine Bamer. In this video, I want to introduce digital performance management, a closed-loop problem-solving solution that helps identify, prioritize, and solve the biggest issues that impede manufacturing productivity. Manufacturers face daunting challenges, from maximizing resources and efficiency to reducing costs and meeting customer demand. The data they need to inform decisions may exist across various manufacturing systems, but they struggle to efficiently gather this data to inform decisions about how to allocate resources in a way that drives business impact and transformation. Digital performance management helps tackle these challenges by helping factories monitor current performance, identify and focus improvement efforts on their biggest bottlenecks, prioritize the issues causing the most time losses, analyze production losses to find root cause loss reasons, improve performance with targeted actions, and confirm the value of improvement efforts before rolling out changes to multiple lines or facilities. Digital performance management stands out against other OEE-type solutions because it collects and normalizes production data to a single standard metric, time lost. To show you how this solution works, we'll visit PTC's headquarters, where Philip is assembling lithium-ion pouch cells, a component of electric vehicle batteries. Here, he's working at the stacking robot work unit in the pouch cell assembly work center. The stacking robot is designed to simulate this same work unit in a real battery production line called cellfab in the PEM Institute in Aachen, Germany. To assemble a pouch cell, the stacking robot grabs an electrode, places it in the QA area for verification, then moves it to the housing. The robot repeats these steps for a separator, then repeats this entire process until the housing is assembled. Philip can now close the pouch cell and move it to the next station. The stacking robot is only a small step in a complex production process involving electrical, chemical, and mechanical components in a heterogeneous manufacturing environment. The pouch cell production process alone consists of other work centers for mixing electrode coatings and electrode processing. We're focusing on the stacking robot work unit because it's the pacemaker of the cell assembly process. The pacemaker is the rate-limiting step of an operation, work center, or line. It's a critical asset to monitor and optimize on the line because its design speed is intended to dictate the output of the whole line. A bottleneck is created when any work unit operates slower than the pacemaker and restricts capacity. Any work unit on the line, including the pacemaker, can become a bottleneck. We'll use digital performance management to determine where we have bottlenecks in the battery production process and the specific actions we should take to fix them. Before we can see how the solution can help, we need to understand our goals. Over the last few months, electric vehicle sales have soared, spiking demand for lithium-ion batteries. Currently, we're not running production fast enough to meet this demand, even with an 8-hour shift of overtime on the weekends. In this video, we'll learn how our operator, plant manager, production supervisor, and maintenance engineer can use digital performance management to find and remove bottlenecks and recover production hours to fulfill more of this demand. We'll start with the perspective of Philip, our operator at the stacking robot, where he's using the solution as part of his daily routine. Philip has noticed a recurring problem at his work unit. The robot is stopping production due to a robot safety stop, which occurs when the robot encounters an unexpected force. He doesn't yet know the cause of the stop. Digital performance management receives most data from automated systems, like the sensors on this robot, but it also takes manually entered data from operators for a more complete picture of the stoppage impact. Let's see how Philip uses DPM to include his own input. Philip's production dashboard shows him everything he needs to know as an operator, including his current job order, his actual and ideal cycle times, the current OEE, and automation events in the events log. Philip's shifts are divided into 1-hour production blocks, giving him quick visual performance feedback. Ideally, these blocks would be green, but the yellow and red bars suggest there are issues impacting his performance. On the production dashboard, the production count automatically updates during every cycle of pouch cell assembly. This is possible with Kepware, PTC's industrial connectivity platform, which allows real-time data connection to the stacking robot PLC. This enables DPM to automatically reflect production counts, scrap counts, and error codes in real time. At the end of each production block, Philip logs his progress to make sure he's accounted for all his time losses. With an ideal cycle time of 2 minutes, Philip's target is 30 batteries. But during this production block, he only made 21 batteries, losing 18 minutes to scrap, slowdowns, and unplanned downtime. To track his progress,